For decades, Nvidia was synonymous with high-performance graphics for PC gaming. Yet, industry analysts now point to a strategic transformation, positioning the company not merely as a hardware vendor, but as the foundational infrastructure provider for the artificial intelligence era. This pivot, initiated years before AI's mainstream explosion, represents one of the most significant gambles in modern tech history. Sources close to the company indicate an early belief in the GPU's broader potential, far beyond rendering pixels. This deep dive explores how a graphics card company became the world's undisputed AI superpower, redefining computing itself. Nvidia's initial success was undeniably built on its prowess in graphics processing units. Established in 1993, the company quickly became a dominant force in the gaming industry, consistently pushing the boundaries of visual fidelity. By the early 2000s, reports confirm Nvidia's GeForce series graphics cards were market leaders. This dominance wasn't just about better graphics, it was about designing processors capable of handling massive parallel computations required for rendering complex scenes. This core competency in parallel processing, though initially for gaming, inadvertently laid the intellectual and architectural groundwork for a far greater ambition in general-purpose computing. The true catalyst for Nvidia's shift occurred in 2006 with the introduction of CUDA, a proprietary parallel computing platform. Industry analysts credit CUDA as the pivotal strategic decision, allowing developers to program Nvidia GPUs for general-purpose tasks, not just graphics. Prior to this, GPU programming was largely confined to graphics APIs. CUDA unlocked the raw computational power of thousands of cores on a single GPU for scientific simulations, data processing, and crucially, early machine learning algorithms. This move, as documented by tech historians, was a gamble on an unproven market for GPU computing, but it forged a crucial ecosystem. With CUDA, Nvidia began a deliberate pivot from consumer-centric graphics to enterprise-grade computing. Market research indicates that by the early 2010s, academic researchers and early-stage AI startups increasingly leveraged Nvidia GPUs for deep learning breakthroughs. The shift was profound. GPUs, designed for visually intensive tasks, were perfectly suited for the repetitive, matrix multiplication operations central to neural network training. This evolution signaled a move from rendering individual pixels to processing petabytes of data, effectively making GPUs the indispensable workhorse for the burgeoning field of artificial intelligence. Nvidia's commitment to AI computing solidified with its focus on data center products, notably the Tesla series and later the A100 and H100 GPUs. These specialized chips, unlike their gaming counterparts, are engineered for relentless, continuous operation in massive server farms. Industry reports reveal that the demand for these data center GPUs has surged exponentially, becoming the primary revenue driver for Nvidia. For instance, recent financial statements show data center revenue surpassing traditional gaming revenue, a dramatic shift from a decade prior. This investment transformed Nvidia into the central nervous system of global AI infrastructure. The value of Nvidia's GPUs in AI primarily stems from their unparalleled efficiency in both training and inference tasks. During training, massive datasets are fed through neural networks, requiring billions of calculations. Sources estimate that training advanced models on CPUs would take months or even years, whereas GPUs can complete the same task in days or weeks. For inference, where trained models make predictions, GPUs provide the low-latency processing critical for real-time AI applications. This dual capability cemented Nvidia's dominance, making their hardware indispensable for anyone developing or deploying AI. Nvidia's strategic foresight and technological superiority have translated into unprecedented market dominance. Industry reports indicate that Nvidia holds an estimated 80 to 90% market share in AI data center GPUs, effectively establishing a near monopoly. This unparalleled position has propelled its market capitalization to historic highs, with its valuation soaring into the multi-trillion-dollar range, as reported by financial news outlets. This meteoric rise reflects investor confidence not just in Nvidia's current technology, but in its integral role in the future of artificial intelligence, making it one of the most valuable companies globally. Nvidia's influence extends far beyond data centers, powering AI applications across virtually every modern industry. From accelerating drug discovery in pharmaceuticals to enabling autonomous vehicles and enhancing predictive analytics in finance, Nvidia's hardware is foundational. Companies worldwide leverage Nvidia's platforms for generative AI, large language models, and robotic control. While some challenges, such as supply chain constraints and increasing competition, are noted by market observers, Nvidia continues to invest heavily in R&D, focusing on new chip architectures and software ecosystems. Its future remains inextricably linked to the ongoing expansion and evolution of artificial intelligence.